Today's lesson is on how to use matrix multiplication for geometric transformations. So in the last lesson you learned how to do matrix multiplication, and in this one I'm going to show you an application of matrix multiplication. A geometric transformation, there are different types. One is rotation, or there's also line reflections, and there's dilations are the main three geometric transformations. For a warm-up question, I'd like you to take the point 10, 1, so here's a little coordinate axis, and here's the point P, which is located at 10, 1, and I want you to write down where that point would end up after each of these four transformations. So if I take P and I rotate it by 90 degrees, where there's new coordinates, 180 degree rotation, 270 degree rotation, these are all around the origin. And well, here's a line reflection. What if I reflect point P over the line y equals x? So that's the warm-up. Everyone do those four questions. Okay. The answers to the four questions. For the 90 degree rotation, it ends up over here, which is at -1, 10. And in general, if the point was xy, it turns into -y, x. You can see how this 10 matches up with that 10, but this -1 is the negation of the y. For question number 2, when you rotate 90 degrees more, it ends up over here, which is at -10, -1, and in general that 180 degree rotation becomes -x, y. For the third one, if I rotate another 90 degrees, it ends up over here, which is at 1, -10, and in general a 270 degree rotation is y, x. And for the last question, if I take the line y equals x and I reflect point P over it, it ends up here, which is 1, 10, and in general the reflection over the y equals x line, xy becomes y, x. This is a little review of geometric transformations. Now we'll see what this has to do, how this is related to matrix multiplication. So we're talking about applications of matrix multiplication. In the last lesson you learned how to multiply matrices, and it seemed kind of unusual, but here's one example. Let's say we have some sort of track meet, and there's two teams, Team A and Team B. And the way this works is that for every first place finish, you get 3 points. For every second place finish, you get 2 points. And for every third place finish, you get 1 point. And here's the situation. Team A has 5 first places, has 2 second places, and 2 third places, whereas Team B has 4 first places, 3 second places, and 2 third places. And we can figure out what team wins pretty easily by working out how many points each team has accumulated. I'm going to show you how that could be done with matrices. If I make 2 rows, one for Team A, one for Team B, and in the columns I have first place finishes, second place, this is first place finishes, second, third place finishes. I end up with a 2-row by 3-column matrix that looks like this: 5, 2, 2, 4, 3, 2. If I were to multiply that matrix by the 3 by 1 3 rows by 1 column matrix, 3, 2, 1. This 3 stands for first place points, second place number of points, third place. First thing to notice is that because this is 2 by 3 and this is 3 by 1, and because these two numbers match, it is possible to multiply them, and the dimensions of the product is going to be 2 by 1. And when you work out what those two elements are, we start by getting take the first row with the first and only column. 5 times 3 is 15, plus 2 times 2 is 4, that gives me up to 19, plus 2 times 1 is 21. Whereas if I do the second row, only column, I get 4 times 3 is 12, plus 3 times 2 is 6, that brings me to 18, 2 times 1 is 2, and we end up with 20. And we can see that by multiplying these two matrices together, we accomplish the same calculations that you would do in working out which team was the winner of the track meet. So that's one example of an application of where matrix multiplication can come up in some sort of real-world application. But today I want to show you another application is that when you have a matrix like 1, 2, 3, 4, 5, 6, 7, 8, 9, that's a 3 by 3 matrix. If I multiply it by the 3 by 1 matrix XYZ, 3 by 3, 3 by 1, these match up, so the answer is 3 by 1. Look what happens when you actually do the multiplication. When you multiply to get the first row, first column, we combine the first row with the first column. We get 1 times x, 2 times y, 3 times z, or x plus 2y plus 3z. And if you do it for the second element, you get 4x plus 5y plus 6z. And if you multiply to get the third element, we get 7x plus 8y plus 9z. So more importantly, we can go backwards in this direction, factoring something like this into what's called a coefficient matrix. And that's another application. So for systems of equations, this will actually become one of our main uses of matrices in a few lessons. Okay, so